Okay, so indicator 3, day 2, and you still are going to be solving for a variable. And the only difference between day 2 and day 1 that we did yesterday is that on yesterday's homework, every single problem was solved for y. Today's homework, it's going to be a different variable every problem. So each problem you need to look for which variable you're solving for. Okay? So that's kind of the only difference. And then one thing I do want to just clarify or specify before we go on, because we will need it for today and tomorrow's work, is I've kind of used slang to talk about it, and I want to make sure that you understand the mathematics underneath it, because in today's problems they get a little bit harder and you kind of need to know the math of it. So I'm going to use our jump start as an example. And so our jump start was 4 equals 1/3 xy. And I said earlier, but I'll say it again so it's on the recording, right? So the 1/3, the x, and the y are all attached by multiplication. That means if you think about it like multiplication, marriage, when you're married, you become one. That is all considered one term, okay? It's a big, long, fat term, but it's all one term. And so we want to get the y by itself, because on our jump start, the directions said solve for y. So we want to get y by itself. And we know that to do that, we need to get the 1/3 off of there, and then we need to get the x off of there. Well, let's deal with the 1/3 first. And so because this is all one term, I'm going to put parentheses around the whole thing, and I'm going to multiply by that denominator. And then, of course, I'm going to come over here and do the same thing. And we've never really talked about it. We've just kind of said if you multiply by the denominator, it goes away. Well, that's true, but that's not really the math reason behind it. So the math reason behind it, I'm going to come over here, is if you have 1/3 and you take it times 3, really it's 3/1. We never write it, but it's really there. Okay, so technically this is 3/1, and over here this is technically 3/1. And we know the rules of multiplication is that you multiply straight across the top. So 1 times 3 is 3. And you multiply straight across the bottom, and 3 times 1 is 3. And then when you reduce 3/3, you get 1. So basically what we've done by multiplying this 1/3 by 3/1 is we've reduced this to 1 and this to 1. They were already 1. And we've reduced this to 1 and this to 1. So that's what I mean by they go away. Basically, they all get reduced to 1, and then what you're left is, and we never write it, but what you're left is 1xy. But we just never write that 1, right? We just write xy, and we've made the 1/3 go away. But that's the mathematical reason behind how that works. And then over here, you've got 3 times 4. Well, again, really it's 4/1. We just never write that. And so when you multiply 3 times 4, you get 12, and it's 12/1, but we just write 12. And then we're going to divide by x for the same reason, because when you divide x by x, they cancel out to 1. And that's what we mean when we say they go away, is they cancel out to 1, and you're left with y equals, and then over here, you're left with 12/x. And that was the answer to our jump start. Okay, so in today's problems, we're going to have some more fractions to get rid of, but they're not going to be just 1/3. Okay, they're going to be a little bit thicker than that. And so I wanted to go kind of the math behind why we do what we do. Okay, any questions on that? All right, so for our first example, get my little paper here. All right, we've got A equals BC plus D. And we are going to solve for B. And when I write for B, I mean solve for B, okay? So with these on day 2, when you're solving for a different variable each time, it's called the indicated variable. This indicates they want us to solve for B. So the first thing we need to do is find B in the problem, and the only one is right here. And then we need to look and see what all is attached and how do we detach it, right? Well, we can see that a C is attached, but it's attached by multiplication. And then we can see that D is attached, and it's that weaker link of plus minus. And so that's the one we're going to break off first, okay? Or we're going to move the D off of that side first because it's kind of the weakest link. All right, so plus D, so we're going to go minus D and minus D. And when I do that, D minus D is 0. And since there's other stuff over there, we don't need to write the 0. We can just write the BC. And then this A minus D, it's a positive A and a negative D. So you could technically also write it negative D plus A. Okay, both of those are the same, and it doesn't matter which way you write it. Both of them, in both instances, the D is negative and the A is positive. I typically get more used to writing it this way, but that's just personal preference, so it doesn't really matter. And in both cases, continuing to get the B by itself, we're going to divide by what's attached to the B, and since it's attached with multiplication, we're going to divide. And the C over C reduces to 1, so we don't need to write that. We can just write B. And then over here, we have A minus D over C, and that is your answer. And then, of course, I would also accept over here, the same thing is, the only difference is you wrote your negative D first, your A second, and then it's still over C. And these are the exact same answer, and both are 100% right. Okay? Any questions on that one before I move on? Okay. Example number 2, we've got WX minus 2Y equals 3Z. And our directions are to solve for X. So first step, find your X's. Well, in this case, we only have one. And then we got a couple of things we need to get off that side of the equation. We have a W, but the W is attached with multiplication. And then we have this negative 2y that's attached with addition subtraction. So that's the first one we're going to move. So minus 2y, we're left with plus 2y. And plus 2y over here. And when we do that, negative 2y and positive 2y go to 0. So we don't need to write that. So the WX drops down. Now we've got 3z plus 2y. These can't be combined. They're not like terms. So we just write them in a big long sentence type structure. And then again, we're trying to get x by itself. So we're going to divide off that w and divide by w. And when we do that, the w and w reduce to 1. And we don't need to write that 1, so we can just write x. And then we've got 3z plus 2y over w, and that's your answer. Can't be reduced, can't be written any different way. That's your answer. Okay? Any questions here? Good. All right, so this next one is an example of when our flipping our fraction comes into play. And there's one just like this on your homework and on the quiz. So I definitely want to do this example with you. So if we have MP over 7 equals N. Okay, and our directions are to solve for P. Okay, so the first thing I want to do is I want to identify where my P is in the equation, and I only have one, and it's right here. And multiplication and division are the same, right? They're opposites of each other, but they're the same type of math. What's the word I'm looking for? Yeah, process. There we go. Big word. So we can look at that M and that 7 and that P. Right now they're 1, right? Because they're married multiplication, married division. That doesn't really rhyme as well or flow as well, but they're all one term. So that M over 7 is considered a fraction. So if I take brackets around this whole term, because it's one term, and if I take the reciprocal of M over 7, which is 7 over M, right? It's the fraction flipped upside down. And then on the other side, I can't forget, I also have M over 7. Nope, I wrote that wrong, didn't I? There we go. 7 over M. I'm going to multiply both sides by the fraction 7 over m. And when I do that, the 7 and the 7 cancel out, and the m cancel out, and my p is left by itself, which is what I wanted. I wanted my variable isolated, and it is. And then on this side, it's not what we're used to looking at, but that's really n over 1, right? So you're going to multiply across the top too. So 7 times n, or n times 7. But in math rules, you just always write the number first. So n times 7, or 7 times n, we would write n7. And then if you multiply the bottom to the bottom, you have 1 times m, which we would just write as m. And that's your answer. So when there's a fraction involved, you get rid of the fraction by multiplying by the reciprocal. And the reciprocal, like I said, it's just a fancy term for the fraction flipped over. And when you do that, and the reason it works is because if you have 7m times m over 7, right, when you do the rules of multiplication, you multiply 7 times m, you get 7m. Here you multiply 7 times m, you get 7m. And anything over itself reduces to 1. So that's why multiplying by the reciprocal kind of, quote, gets rid of it. It's because it reduces it to 1. Okay? Any question on that? I know you've got one like that on your homework. There's one like that on the review, and then there's one like that on the quiz. So I want to make sure that we cover that. All right, something else you're going to see on your homework is the pi symbol. And so I want to do, this is example what, number 4? All right, so if you have p equals 4 pi r. Now it looks kind of weird, but I want you to think of the pi as just another variable, okay? Because that's how we treat it. So our directions are to solve for r. And when 4 and pi and r are all sitting right next to each other, we understand that that's multiplication. So they're married, they're 1, right? That's all one term. And we want to get the r by itself. So we're going to divide, since it's all multiplication up there, we're going to divide by and divide by. Now we are going to divide by the 4, and we're going to divide by the pi, which looks kind of weird, but that's the way it works. Divide by pi on both sides. The 4 and the 4 reduce to 1. Pi over pi reduces to 1. And you're left with r. And then on the left side, you've got p over 4 pi, and that's just your answer. So you treat the pi symbol just as if it was any other variable. Okay, you still add and subtract it off if you need to. You divide it off if you need to. And it just stays pi over in the answer. Okey-doke. And you don't have to put this in your notes, but if you had something like p plus pi equals 4, and we were wanting to solve for p, you would just simply subtract off pi and subtract off pi, just like you would if it was an x, and you'd get p equals 4 minus pi. So whatever you would do if it were an x, do it if it's a pi symbol. Okay, you treat it just the same. All right, I want to do one more. This is like number 8 on your today's homework, so I want to work one more with you, and then I'll get to the bonus question for tomorrow's Khan Academy and work one of those examples for you. So if we have f equals g plus g h I, and we're solving for I. Whoops, I wrote that a little close. Solving for I. Okay, so first thing is identify what you're solving for, which in this case is an I. There's your I. And you ask yourself what all is there that needs to be moved. Well, there's this G hanging out there with the plus, and then there's the G and H that are attached by multiplication. Those are the toughest ones. Those are the tightest bonds, so we're going to leave those alone for right now. We're going to get rid of the G. It's a positive G, so we're going to go minus G and minus G. And again, this is personal preference. I'm going to write F minus G. Whoops. You could write minus G plus F. Okay, doesn't matter. And then the G minus G is 0, and I'm left with G, H, I. And again, G and H are attached by multiplication. So I'm going to divide by GH. And I'm going to divide by GH. And I get I equals, let's do that in black. I get I equals F minus G over GH. Now, from my homework, I am good with this right here, okay? But for Khan Academy, you might see it reduced a bit. What time are we out of here? 2:05? All right, we got 5 minutes. You might see this reduced. Remember when I said when you distribute, you multiply everything? Well, when you divide, you distribute that division as well. So this can actually be written as I equals, don't put your stuff away, guys. We have one more example, and you'll need it for tomorrow's homework. F over GH minus G over GH. And then technically the G's would reduce to 1. And your answer would be I equals F over GH minus 1 over H. Now, for me, don't go to that extra trouble, okay? I don't need it. It's fine. You don't need to go to that trouble. This answer right here is fine for me for my homework. But I just wanted to show you that when you have some common things on the top and the bottom, sometimes there can be some reducing that can happen. All right, I want to take the last few minutes, and I want to do an example from what you're going to have. So for tomorrow, you're going to have, for today, you're going to have day 2's homework. For tomorrow, you're going to have the Indicator 3 review because we are quizzing on Thursday. And then you've got one Khan Academy. And the Khan Academy is a challenging one. There's a video that I've assigned to watch. It's only like a 6-minute video where he explains it. I'm going to explain it. Then I want you to try the Khan Academy a couple of times. Try it 2 or 3 times. As long as you try it 2 or 3 times, your best grade is going to be worth points. Okay? If you only try it once, whatever grade you got, you got. Okay, that's why I said I'm grading you on your effort here. If you put in the effort and you try it 2 or 3 times, then you're going to get an A on the Khan Academy, regardless of what score you got. Okay, please know I can pull it up and it tells me how much time you spent. So if you spent 45 seconds taking it 3 times, I'm going to know you didn't try. So please try. Do your best. Each one, it should take you about 10 minutes to go through it. If you don't do well, try it again. If you don't do well after that, I'm fine as long as you try it twice, but they're real good tries, okay? All right, so here's what you're going to be looking at on these Khan Academies. So write down this example. Let's see, you've got X plus C equals minus 4X plus G. And the directions say solve for X. Okay. So first thing needs to happen is we're solving for X. So we're going to move all of our X's over to the left. Well, that means this gets moved. And, well, shoot, I'm sorry, just add something to this, to your problem. Add a G right here. It has to have something in front of it, sorry. Add a G at the very beginning of the problem. If I don't add that G, this doesn't work. All right, so now I'm going to add 4X over here. Well, when I add 4X, I can't add it to GX because GX is not a known number. So I have to leave them separate. So I have 4X plus GX. Can't combine them because I don't know what G is. Plus C equals G over here. Okay? And they have to be identical to add them. So I can't combine FX or 4X and GX. Now I want to move that C because it's not an X and I want to get it out of the way. So I want to get it over here. So minus C. So I'm left with 4X plus GX equals G minus C. Now, if I were to tell you that, I'm just doing this over here really quickly. If I were to show you that, you would know to distribute, right? You would distribute the X to both and you'd get 4X plus GX. Well, over here, 4X plus GX, instead of distributing the X, I'm going to rip the X out of there. I'm going to pull the X out. So I'm going to pull this X. I'm going to undistribute that X out front, right? So I'm going to take it away. And what's left is 4 plus G. Okay? So I undistributed the X. Now I'm solving for X, and I wanted X by itself. And now attached to my X is this whole little 4 plus G. So I'm going to divide off this whole 4 plus G. And I'm going to divide it from this side too. running out of room here. And when I do that, my 4 plus g over 4 plus g reduces to 1. I have x by itself. And on this side, g minus c over 4 plus g, and that's your answer. So for the ones on Khan Academy, if you've got more than one kind of x and you're solving for x, get all of the x's over to one side and then pull that x out. And then what's left behind is what you'll divide by. Watch his video. He explains it too. It's about like a 5 or 6 minute video. It's on Canvas already, or it will be at 8 o'clock in the morning is when I have it set to publish. But watch his video. Try the Khan Academy. There's only 4 problems, so try it a couple of times. Put a good 15, 20 minutes into the exercise, and I don't care what your grade is, you're going to get an A, as long as you put the time into it, okay? Good? And then when we quiz on Thursday, the bonus question will be like the Khan Academies. All right, for those of you at home, make sure you write all of your notes down in your 3-ring binder from all of today's examples, and then there's an assignment for today. There's a review for tomorrow. There's Khan Academies tomorrow, and then we quiz on Thursday. Let me know if you have any questions.